And good morning, my superhumans. I can see the VU meter in OBS, so hopefully audio is working, and hopefully it sounds reasonably decent. And Guru says, love a good challenge. Yes, that is definitely the case. So, I was screwing around with my camera system, and what I had set up last night stopped working. I couldn't get the normal 1080p resolution out of the camera, so I've ended up switching to my Panasonic camera, which is the one that I normally use for, it's my primary camera. It's what I use for doing videos. And I also, thanks to the extreme generosity of Guru of Nothing, who you can see in the chat right there, I'm using a new microphone. So Guru sent me a really nice Comica, I think that's how you pronounce it, microphone. And I've currently got that. It's like it's a directional microphone that you would normally have sitting up on top of a camera, so that you can record sound directly in front of the camera and hopefully cut out all of the background noise. So I currently have that sitting on a little tripod just in front of my computer, pointing at me, and if you can hear me okay, that's fantastic. No one said they can't hear me, so... Oh, Dodgy says you can. Great. Alright, so, camera is okay. Audio is okay. I was almost on time. Thanks, Mr. Domingo. I was close. Alright, so, I hope you're all doing well this morning. It is a very sunny but cold day this morning here in Melbourne. Probably about the last sunny day we're going to have for a few months, maybe. It's supposed to rain starting tomorrow and going on. Hey, thanks, John. So, John Spencer is here. Fantastic. John is in Melbourne as well. He's a friend of mine from the local hackerspace. And in the past, I've mentioned the amazing Clear game console that he built. So, like a MAME arcade sort of thing that uses... that he's made up using clear acrylic sides and put LEDs in it, and it looks incredible. Looks like something off a sci-fi set or something. Okay, so far two of the three things are working. Oh, Stefan, hi from Sweden. So it's interesting to see all the different places that people are coming in from. And, back on that subject, I just want to say a big thank you to Guru of Nothing for sending me this microphone. That's incredibly generous. So Guru is one of the moderators both in the forum and the Discord, and has done some really cool videos of his own. He's got a channel where he has a project called the Package Guard, which is a system for securely receiving packages. And I wasn't prepared for this, but if I can pull it up, I might drop a URL into the chat. I might do that at the end if I don't find it in the meantime. And so his project is to build a large steel container that you can have, in his case, at the end of the driveway. And when a delivery person comes along, like a UPS or FedEx or whatever, they can open the lid, put the package in and close it. The system then detects that a package has been put in, and it locks so that someone else can't come along and steal the package. And that is a really, really cool project. There's a project that I followed on Kickstarter a few years ago, which was called Package Guard, and that was a thing that was basically like the size of a set of kitchen scales, and the idea is that you bolt it down to your front door, and it just measures weight. So a delivery person can come along and put a package on it, and the package isn't physically protected, but if it's picked up without the system being disarmed, then it sets off an loud alarm and does other things. And that Kickstarter fell through, but I've had in mind for ages that I want to build something like that as well. And what Guru has built is like next level. It's an actual vault that protects the package and is linked in, I can't remember what sort of link it uses, but there's a notification system in it, so you can see when a package has been delivered, it records video and all that sort of thing. So, awesome project, and thank you very much, Guru, for sending me this microphone. Dodgy just asked, what is that yellow thing on the desk behind? And which side? Right there. That is a robot of sorts. And if I move the other way, you can see a big grey thing right there. That is another robot of sorts. It's, well, I say robot because that sounds cool. It's actually a water cannon. That's the thing that sits on the top of a water truck, and a big pump pushes water through it. And this is like a pan tilt mount with a very large pipe. It's like that sort of diameter, and there's a nozzle on the end, and it's like an enormous version of one of those twist nozzles you can get in just on your hose. So you can twist it to adjust whether you want wide spray or narrow column of water. And that's a project I'm doing at the moment for a contracting client. It's a company called T-Rex Water Trucks, and they build trucks that are used for things like road construction and in mining, and used a lot by councils for doing things like watering nature strips. So the water truck can just drive along and they've got this big sheet of water that comes out the side and it sprays the nature strip. And they've got a whole bunch of them at different sports facilities where they need to do watering of either very large areas or Raspberry said, looks like a monitor on the front of the fire engine I drive. Hey, so you're a fiery. Awesome. Yeah, that's basically what it is. It's a monitor. But if you say monitor, most people don't know what you're talking about, or they think you're talking about a computer monitor. So, Unexpected has joined us as well. Hey, Sion. So we've got a whole bunch of people. Hey, Simon. So Simon, who is in the chat here, is the guy who owns T-Rex water trucks. So Simon is the one who builds the trucks that this thing is to go on. Now, in the past, Simon has let me take photos of this and publish it. So hopefully this is okay to be talking about this. I'm not showing the design or any details of it, but it's a cool project to be working on. It's really, really interesting. You can see just down, everything's backwards. You can see just down there, there is a grey box with a red button on it. Because of the very short depth of field of this camera, it's all out of focus, but that's a big emergency stop button. So if I'm moving it around and something goes wrong, I can just smack the E-stop and it cuts power to everything. So hopefully I don't break anything. Hey, thanks, Simon. That's good. I won't reveal any of your secrets, but it's a really cool project, and it's fun to be working on something like this, so it's cool to talk about. Okay, so, oh yes, good. So Guru has put in a link to the Package Vault project. That is his project to build a box that secures packages when they're delivered. So go and check that out. Alrighty, so Unexpected said, did I just break any NDAs? Well, Simon's in the chat and he says it's okay, so it's all good. Yeah, so Raspberry said we usually run them at 80 psi for wildfires. Just give me a second. Because we're going to try to pull another crazy stunt and see if this works, which could be a total disaster. This might take a little bit of patience and it might take a whole lot of fiddling, but what I have wanted to do right from the start of when I resumed these live streams was to make it be not just me talking to you, but to try to get other people on as well. And the technical difficulty of doing that is actually surprisingly high. I would have thought that it would be much easier to be able to live stream and then bring other people in externally, and there aren't really great solutions for it. There are ways you can do it using external meeting services like Zoom or StreamYard is the one that's used by the MakerCast every month. And the way they work is that they have an external service, and each member joins it, and then the stream goes out from there. So all the control is done through StreamYard. But that then limits you if you want to be able to use something like OBS locally to generate your stream and then push it up to StreamYard, so that you can do things like switch to desktop view and multiple cameras and all of those really cool things. Alrighty, so as a test, let's see if we can get someone on the phone, because I would really like to be able to bring people in and ask questions. It's fantastic having people here in the chat asking questions, but it would be even more cool. Let's see what's going on here. And do we have a call? Hello?
Hello.
Hey, Sion. Now, hang on. I've just got to switch my video setup across because it's in OBS. This source is not seeing it. So, what do we need to do? All right. I know, it's my crazy stunt. So let's try. Oh, Xeon, there it is. Okay. Let's see if I can bring you in here. Yes! I can see you. I don't know if anybody else can see you. Oh, James said we heard him. Dodgy said, yeah, is this phone a friend? Yes, it is phone a friend.
This is super laggy. I've got two cameras open so I can see the chat on two windows.
Mm-hmm.
And all three of them are out of sync.
Okay, so the trick is don't look at the screen. We'll just talk to each other, because the audio to me doesn't sound laggy at all. Like I can, oh, it says audio is low but it works. I wonder if I can do anything to adjust your audio level.
Let me see if I can lift my microphone.
Okay,
as well.
Sure.
So me talking to you in Skype,
yep.
Your audio is not in sync.
Oh, really?
Yeah.
That's interesting. So maybe my audio is going via OBS and back into Skype because I'm using NVI or NDI to do the injection. Okay, cool. This is cool. So, in that case, it's going to drive you a little bit nuts because of the lag. Oh well, we'll see if we can get through it. I'd really like a better solution than this, but this is just a... Graham said, well, using the wonders of technology to talk to the guy next door. Yeah. Yep. Yeah. Yeah, in heavy traffic. Cool. Well, it's really good to see you. For those who don't know, I'll do a little bit of an intro for Sion. Oh, that's good. No, it's fine. So, for those of you who don't know, Sion is the unexpected maker. So if you're seeing comments in the chat by the unexpected maker, that is Sion. And I'll just put in your website URL here. I'll drop a couple of links in, and later I'll put these into the video description as well, so they can be found later.
Yeah, they're saying that they can't hear me at all now. Whatever you changed, maybe.
Oh, okay. All right, I did not change anything, but what I'll try doing is I've got an audio level for Skype NDI. I'm going to bring that up, and I'm going to...
I can hear you fine. Okay. I just lifted mine. I lifted my microphone input volume a bit as well, but I'm scared that it's going to start distorting.
Okay. Yeah.
Distorting.
All right.
So.
I've just yeah. So people couldn't hear me when I pulled it down.
They can hear mine. They can hear mine. They can't hear you now.
All right. Sorry, I've gone back to the original setup, which hopefully will be okay. Way better. Both sounds all right. All right. Now we're somewhere. All right, so I've dropped in way back. It's scrolling back up now, but I dropped in Sion's channel. So if you're watching this, go and subscribe to Sion, because if you like the stuff I do, yes, I do. It's the law. Because if people like my videos, they will like yours too. And the project that Sion is probably most well known for is the Tiny Pico, which is, oh, people are saying they can't hear you again. I'm going to bring the Skype NDI level up just a little bit and bring my level. I don't know if this is going to make any difference. All right.
Test.
We're. Oh no. Well, I did say that this was living dangerously and it could fail.
Yep.
Yeah, Matt's suggesting looking at something like voice meter. Okay. I'm going to leave NDI low and my own up and the normal mixing level up, and hopefully everything will balance out in the end. So some people are saying it seems okay, some can't hear it. We'll just have to struggle through. Hopefully people can lip read. So the the project I was mentioning, Tiny Pico. So this is the project that Sion has been working on for quite a while. Oh yes, and holding one up. In fact, I have one here too, so we can do stereo Tiny Picos. And this is an ESP32 development board, which is an amazing little board. Just for scale, there is a regular size Arduino next to it, so it's very, very small. It's down in like the Arduino Nano sort of size. And another really interesting reference is this isn't a Vroom32 module, which is what people typically put on projects if they want an ESP32 on it. Now, they are very similar. The Tiny Pico is just a little bit longer, but the difference is that the Vroom32 is an ESP32 and it's basic supporting parts and nothing else. It's no comparison to the Tiny Pico, which has onboard USB. It's got a better quality antenna. It's got extra memory. There is a full battery management system on this, so you can plug in a LiPo and run this on battery and it will charge the battery. So if you look at these two side by side, they're very similar size, sort of in the same ballpark, but there is no comparison on features. So if you are looking for a very capable, very small ESP32 development board, go and check out Tiny Pico, and I put the link in there. So that is the commercial for Sion, yes.
Yeah, thanks. Can I hire you to do all my marketing? That's awesome.
Cool.
Better job than me.
Well, you've made a really cool little board, so I'm happy to promote it. There are many things I could talk to you about, many reasons I wanted to get you on. There is one thing I've been really wanting to talk to you about, which follows on from my comments last week about Dick Smith's fun way into electronics and electronics education. And also I saw I should have grabbed this at the time, but yesterday on Twitter someone posted a picture which was someone wanting to get into electronics. It was a picture of someone going up a flight of steps, and there were labels on the steps, and there was basic electronics knowledge, and Arduino was higher up, and the person was stepping over the basic electronics knowledge straight to Arduino. And there was another interaction I saw on Twitter, I think it was yesterday or the day before, and someone asked the question, I'm a software developer, I want to get into hardware, should I get a Raspberry Pi or an Arduino? And my instinctual response to that is get some transistors and a breadboard and some resistors and like make an LED blink. Like, don't go for essentially a small computer if you're wanting to get into electronics. So the path, there are a couple of different ways to approach this. The way I came at it in terms of learning electronics was from very simple parts like switches and lights, and just turning lights on and off and making motors run, and then building things up from there. And a whole lot of other people come at it from the point of view of the software world and then coming down the stack to microcontrollers, and then from microcontrollers learning about the electronics that go into it, like how to add sensors and those sorts of things, and then work down to the component level, which is almost the exact opposite path. So
that's actually the path I took.
Yeah.
So you just explained me completely, right? We're opposites on how we both came to it. I also started with the Dick Smith stuff, the electronics when I was young. My dad bought me the books and the kits. He was trying to get me to play with the electronics, and I found that I was kind of bored with the just replicating what it told me to do. I wanted to understand things a bit more.
Yes.
But I could just, I never, like as soon as maths came into it, and fundamentally when you're playing with electronics, there's a little bit of maths involved. You can't really play with a capacitor unless you understand kind of how a capacitor works and what it does, and then suddenly you're at maths, even if it's simple maths, right? I mean, even Ohm's law when you were a kid, I saw maths and I thought, ugh. And so my whole life, I've really wanted to play with electronics. I've really been intrigued, not digital, but actual electronics. And every time I started, I went to Monash Uni and I did digital robotics as a course. I did it twice. I started the course twice, 7 years apart. But I still dropped out both times when the maths got heavy, because I just, it was a real roadblock for me. And when I found micros, I was always really good on the digital side. From a programming point of view, I could do Boolean logic with one eye closed and one eye looking out the window, but I couldn't do differential calculus, and I couldn't do all those
like RC networks and all those sorts of things.
That's right. I couldn't do them, right? And still now I'm intimidated by them. But so when digital electronics came around, that was easy for me. And so that's why I started playing with microcontrollers, although I came into it late. I got my first Arduino board. I think it was a SparkFun Red board, only 3 years ago. Like, that was my first microcontroller. Because I put it off for a long time, because I thought to myself, if I start playing with microcontrollers, I'm going to have to do maths again. So I didn't do it, right? But finally, when I wound up my games company, I had a lot of free time, so I grabbed a SparkFun board and I started playing, and I was able to make it do really cool things because it was a software and a digital thing. And slowly I could introduce the electronic side, right? And then I've been pushing further and further and further. Like, if it wasn't for that, I wouldn't have been playing with electronics still, because even now I look at data sheets for MOSFETs and transistors, and I look at the maths and the graphs and the this and everything else, and I zone out.
Well, I think that sort of approach to it is really interesting, because in many ways what that is a representation of is the modular approach I've talked about in the past as well. Because when you start off with, say, an Arduino type board and you add some sensors to it and some actuators or whatever, you can treat those as mini black boxes. You don't necessarily need to know how the sensor part of the circuit works. You know that it gives you some data, you connect to it in a certain way. So if you're looking at it from the point of view of like a software analogy, it's like having an external service with an API, and you know how to communicate with the API. You don't need to know how the service works or how it's implemented. But then later on, if you want to get down into the details of that particular thing, you can look inside it and you can learn more about it. So you can progressively reveal the different layers of complexity. So I do think that is a really interesting approach as well. It's just not the path I took. I came at it from the opposite point of view, but I think that makes perfect sense.
Sure. John, people are saying that they can't understand the conversation just because they can't hear me well enough.
Okay.
I'm talking pretty loud at the moment. I feel like I'm shouting at my screen.
Yeah. Well, question is, do we want to continue, or shall we try this a different time once we've messed around with settings and things a bit more?
We can. So the plugin that you're using, can you make it work with Discord instead? Can we try Discord as a source?
Possibly. Yeah.
Like maybe it's a Skype issue. I don't know.
Yeah. The thing is, I've never done video on Discord. I'm just opening Discord now to see what happens.
Yeah, it's pretty simple.
Mm-hmm.
Sorry, folks, for those that can't hear or can't hear well, it's we didn't test this first. We should have done a dry run yesterday, maybe.
Yeah. The problem is I need a second YouTube channel for doing tests.
Yeah. I'm going to disconnect Skype and I'm going to call you on Discord.
Okay. I've never had an incoming call on Discord before, so this will be fun.
Okay, here we go.
All right. Okay, so I'm back to just me with the front camera. And I've got Discord open. And we'll see if I get an incoming call coming from Sion. So, started a call. Join the call. Alrighty.
Are you there?
Hey. So I can see you. I've got no idea if you can see me.
Hello, John.
Yeah. Alright. Turn on screen share. Turn on camera. Okay, there we go. I can indeed. Let's fix that. Visit settings, not detecting any input from your microphone. Microphone, yep. That's alright, I'm going to try to fix it. Voice activity, let's check. Input device. Okay, I've got built-in microphone set now. Can you hear me? No. Alright, let's try display audio as the input. No. Okay. Mic, no. Alright. I think yeah. Peter Kirkhoff said, so what you're saying is an untested setup isn't working? That's unexpected. Yeah. No. Okay. All right, let's bail on this. All right, so I assume that everybody else can still hear me fine, but they can't hear or see Sion. Okay. What I think I need to do is get this working through StreamYard instead of through Skype, because that's a bit of a pain. And also, bringing in people on Skype is okay if I've got something lined up with someone specific. So, Sion, thanks for being part of that crazy experiment. Yeah, Stephen Harrison said, testing in production like all the best software developers. Yeah, so there's that old saying, everyone has a test environment. Some people are lucky enough to also have a production environment that's separate from testing. No, so Sion was just asking whether we should try Skype once more or bail. No, I think the problem is we're going to end up messing around with settings and things like that, and drive everybody nuts. So, so let's try that again another time. Oh, Aaron says try again, but no, I think I've annoyed everybody enough by my lack of preparation. So a big thank you to Sion for being game to try that, and we'll give it another go in future. I don't need that anymore because Sion's audio is now gone. Yeah. Yeah. Alrighty, so what I was wanting to talk to Sion about, there were a couple of other topics as well, and we can come back to that in the future. It would be really cool to have Sion on for an extended period. So what I was wanting to talk about was getting started in electronics education and the different sequence of the way people learn things, either starting from individual components and building them up, or starting from a complex working system and then progressively revealing parts about how it works. And I don't think either of those approaches is either right or wrong. They are both perfectly valid, and I think that trying to combine some of the benefits of both of those methods is good as well. So Daryl suggested I could use an HDMI adapter for your phone and have Skype into your game capture. Yeah. So what I need is more game capture devices. Right now I only have one, and that is what is connected to the camera that I'm using here. So there is an interesting question come up in the chat, but I'll get back to that. So what I have at the moment is I have one Elgato game capture device, which is physically attached to my microscope. HDMI from the camera is going down to the microscope, plugged into it, and then coming back into my computer on USB. And I've been trying to get hold of more USB capture devices. Ideally, I want two more, because I want to be able to have one on the overhead camera that looks straight down on the bench, and then I want another one for I need the microscope and I need the front camera. So as a minimum, I need 3 HDMI capture devices. Okay, so 50 Hertz said, a bit late for the show, but if you have the time, I have a question regarding selling electronics kits. If someone hurts themselves, is there any comeback on the seller? Yeah, okay, so this is a question where I need to preface it by saying I am not a lawyer. From my own point of view, as someone that sells electronic kits, this is something that worries me, and it's also something that is an issue specifically in relation to home automation. And for Freetronics and SuperHouse, I have several different types of insurance that are related to this. Unexpected Maker says, consult a lawyer. Yes, definitely. So I've got professional indemnity insurance and product liability insurance. There are lots of issues involved. Even if you just give advice to someone and they pay for your advice, then there is some potential liability involved. And that's where things like the professional indemnity liability can come in. And and Doug said there's probably a difference between a manufacturer, a seller, and a pure reseller. Yes, that's right. This is a whole complicated area. As a consumer, so an end user who buys a product, imagine I bought a mobile phone from a mobile phone shop down the street, and I'm using it and it explodes and hurts my hand. My commercial relationship is not with the manufacturer of the phone, it's with the reseller that I bought it from. The manufacturer of the phone doesn't necessarily know who I am, that there's no commercial arrangement between us, but there was a commercial arrangement when I purchased the device, and so the first step of remedy is going to the place you bought it from. But then there is also a liability involved with the company that made the device, and that gets into a whole big complicated area. So Aaron suggested a dirty way is to screencast a Zoom call. Yes, but there are issues with capturing the audio. One of the difficulties that I've got at the moment with setting up this the system to bring guests on is that the audio from the guest needs to come to me like through headphones, but also be captured by OBS so that it can be broadcast, and the same with the video. And also my audio needs to go into OBS, but it also needs to go into whatever the program is that I'm talking to the guest on so that they can hear me. So there are audio and video routing issues in both directions. You need to have all the correct things hooked up so that the input from OBS is coming from the right place, etc. Yeah, so in Zoom you'll be able to select OBS for audio and use PC headphones. Yeah, hopefully that would work out okay. So at the moment I've got an NVI plugin in OBS, and then and then Skype is using that to create a virtual audio device and pass the video and the audio across to OBS, and also allow me to hear it. All right, that's a subject that I'll have to get back to, and probably not just chatting about on the live stream. So, live stream. I brought along a couple of things today, and these are things that I was wanting to talk to Sion about because he's done some really interesting things for this, but I will just give my kind of one-sided opinion on it until someone says, oh, shiny thing, and I run off after it going down a tangent. So one of the topics that I wanted to talk to Sion about is test jigs and testing, because he's done some really cool stuff with things like 3D printing, laser cutting of fixtures and jigs and doing that sort of stuff. And I've done a little bit of it as well. So I'll show you a couple of the things. And also this question came up on a stream, I don't know, it was a couple of weeks ago now. Someone right at the end of the stream said, could you talk about test jigs and things and testing? So before I start showing you specific equipment and things that I use, a general principle. One thing that Mark Alexander told me many years ago. So for those of you who don't know, Mark was my co-founder with Freetronics, and then went off to LifeX. So he hasn't been involved in Freetronics for a long time, but in the early days, we worked together on creating some of the first products. And one of the things that he taught me was an approach to creating test systems. And the basic principle is, if you have a design and you want to test it, there are a few different ways to think about ways that it could fail, and then being able to catch those failures. But and they can become quite complicated. You have to start thinking about all of the things like, what happens if the bootloader has failed to be flashed onto it? How do you detect that? What happens if, some other thing has failed? How do you detect that? And it can be quite mind-bending to try to think of all the possible scenarios that you have to cover. But you distill it down to one very specific thing, which is, look at the design of your board and imagine that any single part on this board could be missing, like just gone, not there. How would you detect that? And that is that summary really helps me to understand how to go about setting up tests for things. So if I design a board and I want to make a test fixture for it, I need to have that test fixture be able to detect that this particular resistor network was not placed during the pick and place cycle, or maybe it was placed with a wrong value or something like that. So imagine that any part of this board could simply be missing, so the function is just gone. How do you tell? And when you start thinking about it that way, it makes you start thinking about how the I/O can change. How can you poke certain parts of the board and expect a response, and then detect whether that response is there or not. So, and it's not always possible. I mean, there are certain situations where you could have a thing that could fail on a board, and you can't easily detect it using external testing. Now, with pick and place, there is usually optical inspection. Depending on the complexity of your board, there may be X-ray inspections to check for joints. There's flying probe testing and that sort of thing, where you can measure the values of parts in place. So if you haven't seen a flying probe tester, I don't know if I'll be able to find a video of one. I think I may have actually brought this up on a previous stream, but let's find a flying probe tester. And what these do is use long needles. Oh, here we go. I'm going to bring these things up on my main desktop so you can see it. Where are we? Desktop. Okay. And maximize that. So what you can see here is a whole lot of needles that have been brought in by tiny robotic heads, and they're very sharp test probes. So what you can do is have a machine that brings the test probes in. Oh, and here's another view, which is interesting. So these test probes come in and make contact with different parts of the board. So one approach is to probe the ends of all of the parts, and then use a tester to measure the value of the parts. Now, the value of the part may not necessarily be the same as the part in isolation, because it's going to be affected by the rest of the circuit around it. But you can do things like, for example, measure across an LED and see the voltage drop in one direction, the voltage drop in the other direction, and in that case you can probably tell whether the LED is fitted properly or not. But flying probe testing tends to be done in a more isolated way, where you are testing for specific things. And I'll just pull up a few more pictures because they're kind of cool. So flying probe testers are, when you see videos of them in operation, they're amazing, because they bring the probes in very quickly. It's like gunshots, and they're very accurate, and they come in from different angles because they have to avoid each other, and they've got to come in on the sides of parts, do all sorts of tricky things. But optical inspection is usually a quicker way to do it, because you don't have to mechanically move all the parts in. With optical inspection, you can check whether parts are missing from the board, because it'll just detect that there is a pair of pads there and no board in its place. So so Sion said, in my case with my tiny Pico and matching network, testing that the components are there and in place and soldered correctly can only be done visually. Yeah. As the RF works even without them, just isn't as good, but way good enough to pass any Wi-Fi tests. Yeah, so that's an interesting one. If your device, like a tiny Pico, has a Wi-Fi antenna on it, and you want to verify that Wi-Fi is working, then part of your test procedure needs to be bring up software on the device that is going to exercise Wi-Fi and see if it can do something basic like just scan for local Wi-Fi networks and return a list. And if it finds any, then you know that your Wi-Fi is working to some extent. But as Sion said, that will still work even if the antenna is missing, because if you've got an access point that's nearby, the signal strength is quite high, you could still get a signal through even with even without an antenna on the board. So when you start getting into issues like that, it can be really hard to figure out ways to test it in a definitive way, not just an indicative way. So, Doug Wheeler said, sometimes in one product we have two buzzers, one real and one backup, and in normal use we use the second buzzer as a microphone to listen to the first. That's pretty cool. So for for those who don't know, something like a piezo buzzer can also act as a microphone. You can detect sound with it because when you apply a voltage across the piezo element, it vibrates, which makes the sound. But if you apply physical deformation to the piezo element, which happens when sound waves hit it, it generates a voltage. It's a little bit like a motor. You can put voltage in it and it spins, or you can spin it and it puts voltage out. So that's pretty cool. So what I, taking that approach of thinking about it in terms of imagine any part is missing on the board, that's not a universal solution. That's just a way of getting your mind around the problem and thinking, okay, how am I going to handle this? Now there was one problem, and there are ways this can go wrong. I'll get back to that in a second. There's a story about a part replacement problem that happened early on a Freetronics board. So what I've done over the years is made a number of test jigs. This is a test jig for a free end FET. So this is for a little module that's got 3 NMOSFETs on it, which are driven by a WS2811 addressable RGB LED controller. Same thing as you'd find in like a NeoPixel or something. And the idea is that with this module, it behaves exactly like a NeoPixel, and you can address it with all the same libraries because it's got the same driver chip on it. But instead of being an LED, it's got 3 MOSFETs, and those FETs are connected to the red, green, and blue channels. And then you can use that for driving very high power loads, or you could use it for things like driving relays as if they are NeoPixels. So it's kind of a cool little module. Anyway, that's an aside. But what it allows me to do is test that in a way that is fairly definitive, because I've got inputs on here and I can measure the 3 outputs, and I can detect situations like any of the output MOSFETs failing or the driver chip failing. But it's a relatively simple design, so I can definitively test whether it works. And what I've done on this PCB, so this is a custom PCB which is used for nothing but testing this particular module, and it's got pogo pins on it. Very hard to see, but these are little spring-loaded pins. These ones on the side have conical tips on them, so they're sharp, and then these ones have rounded ends on them because they have to go into a fairly large hole, which is where the high power output from the MOSFETs go. And there is also a switch on here, a little tat switch, and there's a piezo buzzer, and there are also 3 LEDs. So there is one LED and then it goes up to green and down to red, and it's got test first, and then it's got pass or fail. So the LED, it goes green if it passes, red if it fails, and the piezo makes a nasty noise if it fails. It's just sitting on top of an Arduino compatible board which is running the test routine, and it's monitoring for the button on here. So the way this works is you grab the module, sit it in place on the pogo pins, and then push it, and when you pushed it far enough, it activates the button, and that then triggers the test routine. So the test routine then tries to drive the module, and it reads the outputs from it through these connections and sees if it gets the response that it expects. So if the module fails, it'll try to drive it, and then it won't get the outputs, and then it will give the little fail thing coming up. So with this, it means that you can test things like cross-linking between outputs. One of the possible failures, if for example you have an Arduino compatible board and you want to test it, one of the possible failures is something like a solder bridge across the back of the connections. And so one of the, can I go full screen? Good point, because I'm waving stuff at the camera and you can't even see me. Okay, hopefully that's better. So I'll hold that up again. So I'll hold this up again. So that is the test board, and it's got a piezo buzzer on there. There are 3 LEDs on here, so one to show the test has started, and then a red one for fail or a green one for pass. And on the PCB it actually says pass or fail, and it's got the pogo pins where the module sits on top, and the little micro switch. Well, it's a tactile switch that detects when the module has been put in place and then pushed down. So one of the failure modes for a board like this is solder bridges across a couple of pads, for example on an I/O pin. And I don't have one physically here. In fact, most of these testers are in the factory in China, but the test jig that we use for this makes contact with all of the I/O pins, and then we have test software that we load onto it, and what it does is put the first pin into output mode, and then it puts all of the other pins into input mode, and it drives the output and makes sure that all of the other inputs are not being asserted, so that way it can detect for bridges across them. And the test jig also measures that the pin that you're asserting is actually being asserted, so it drives it high and low, basically twiddles it up and down, makes sure that you're getting the output and that none of the other pins are seeing that same output, and then it steps on to the next one and it does the same thing. So it goes through every single I/O pin in turn and measures that it can drive that output and that it doesn't influence any of the other outputs. And all of that takes a fraction of a second. You put it in the test, you press the button and it goes pass or fail, because it's zipping through them so fast. But basically what we do is we test every single possible combination of input and output pins. So that's just one of the many little tests that runs on the test system. So mechanically, this is the sort of thing that is typically used to make the test jigs. Now this is a very small one, and if you go to markets in China, there are shops that are just full of these in all different sizes, and they will customize them for you like in the space of a couple of hours. And this is a very small one. Normally they're a little bit bigger than this, but this is a standardized frame that you would use as a starting point for building a test stand. And the idea is that you can put some kind of a fixture in the bottom here which holds your device under test. So the terminology is DUT, is device under test, and you can see it's got holes on here for like standardized mounting things. So you make a little jig that gets bolted into here, and then your device under test gets dropped into the little spot that holds it accurately in position. And then on the top section, and it can be done the other way as well with pins coming up from the bottom, but on the top section, what you would do is have something like either a PCB or a piece of a laser cut material with pogo pins sticking through it, and that bolts on there. And then you flip this down, it pushes the pogo pins down, you run the test, flip it up, take your board out, put the next one in, push it down, run the test. So David said, is that one customized for you? No, this is just a standard off-the-shelf thing. And when you go to these stores, and you can buy these online as well, like on AliExpress, but when you go to these stores, they'll have shelves and shelves piled up with all different sizes of these. And then this is just a starting point, because these are so common. It's one of those things that most people never see, but in factories where electronics manufacturing is done, they have these everywhere, and they're a really common thing. So if you go to any of the places that supply equipment for factories, you can get these easily. And the idea is that this is a starting point, because the basic structure of the base, the little moving section here, the little cantilevered arm, all of this is pretty much standard. It doesn't matter what the board is that's underneath here. The only real difference is the position of the pins that you want to connect to and the physical size. So yeah, this is a small one, but they come in all different sizes, and you can get multi-gang boards. So you can set up a tester where you put a whole row of PCBs in place and then pull the arm down, it puts all the pins in place, and then you can test all the boards in parallel. But that's the basic common structure that you'll see all over the place. And there are other styles of them. This one is pretty common. This is basically like the simplest possible approach. There is another style which has the same sort of structure as this, with the sliding platform on the top, but it has more like a box underneath it. And those ones are often used if you're having pins coming up from the bottom as well as from the top. What you can do is have an area where you put your device under test in place, and there will be pogo pins sticking up, and then more pins come down from the top. So you clamp the PCB between the two sets of pins, and you can do testing that way. And that is one of the good reasons that you need to think about putting test points on your designs, which is something that I'm kind of slack at. I don't often think about it while I'm in the process of doing the initial board layout. Often I'll get to the point of finishing the board layout and then thinking, how am I going to test this? And realize that I need to put some test points on. So a test point is an area on the PCB, typically where you just have a flat exposed piece of copper that is designed to be able to put a pin onto it and make contact. It's not necessarily somewhere that you want end users to be able to access. It's not something that is an end user feature. It's a production testing feature. Just wondering if I've got an example of something around here. I know what I have. This is the perfect example, and it gets us back on topic of home automation. So this is a Sonoff, which one is it? Mini. Yes. So many models I can't even remember. Sonoff Mini, and this particular one doesn't have the usual programming header. So most Sonoffs have the little 4-pin programming header that gives you ground, power, TX and RX, and this doesn't have it, because what they do in the factory is use see, there is a topic sometimes. So what they do in the factory is use a jig that is very similar to this, with pogo pins to make contact with little sections on the pads. Now, because of the scale, you're not going to be able to see this, and I can't put it under the microscope because I'm using my capture device on the camera. But on the bottom of this PCB, there are some, I'm trying to point, but you still won't be able to see. There are some tiny little circular exposed metal areas, which are the connections for programming. So there's ground, there's actually there's a reset pin, GPIO 0 is exposed on there, there's TX, RX. So this is a project that I've shown some teasers of in the past, but I haven't done a video on it yet. I got sidetracked by a topic that I might come back to, unless I see a squirrel. So this is a 3D printed programming jig for a Sonoff Mini, and what you can just see here are the little sharp pins sticking up. These are pogo pins, they're spring loaded, I can push them down, and there's a structure to support the Mini. So what I can do is hook the PCB in here, push it down, and the guides hold it in the right position, and those pins are now pushing onto the bottom of the PCB using their little spring-loaded backs on them and providing contact. So then on the side here there is a header, so there's a female header on that. What am I having for lunch? Okay, dodgy. Don't distract me. So what this allows me to do is take a board that is normally very hard to connect to. It's just got these exposed test points on it, pop it in here, and now those test points are exposed on a standard 0.1 inch pitch header, and then you can plug whatever you want into there and you can reprogram it. So the inside this structure is a PCB. This is 3D print is 2 parts that have been screwed closed. You can see the bolt heads on there. In the middle is a PCB which has got the pogo pins on it and the header. So let's see. Oh, here's one that is kind of in pieces. This was a messed up print because I had to iterate through a couple. You can see the two halves there. So this half would normally have the PCB sitting in the bottom of it, and I have a PCB here, and the PCB has the connector on it coming out the side, and it's got the holes where the pogo pins go through. This particular one doesn't have the pins in it, but what would happen is that the PCB sits into the bottom part of that 3D printed fixture. The pogo pins would be sticking up, and then this goes on top with the pin sticking through, and then you bolt it together. And the end result is that, a little pogo pin programming / test fixture. So yeah, so this is kind of an example of how you would set it up with one of these. In fact, what I could do is mount this in the bottom here, and you have this over the top. I'd need to adjust the mechanical clearance a little bit, but what I could do is put a shape on here that pushes down on the back of the PCB. So I could slide the Sonoff Mini in there, pop that down, and it would push it onto the pogo pins and then do the programming. Alright. Yeah, that whole thing about there is a topic. I need to learn how to stay on topic. Alrighty. Oh, Aaron said, are the files available for the programmer, or will I sell it? I'll do both. I'm going to release the files. Okay, so this gets back to the other squirrel topic. The reason I haven't actually done this yet, thanks Scott, is the whole debate over the order of the pins for a programming header for an ESP32 and what those signals should be, whether it should be 3.3 volts or 5 volt supply or whatever. And oh, here's a, so this was my first iteration of the of this programming jig. I'll get back to that header in a second. So before I did this one, which has the custom PCB inside it that holds all of the pogo pins in place, I did this version, and this doesn't have a PCB. It has the pogo pins going down into a little holder underneath, and then it's just, I've just hand soldered wires onto the pogo pins, which is kind of dodgy, and then it comes out to a header that I've just typically in place on the side. So this one works, but it's not nearly as nice as this one. So what I'm going to do is I'm going to do a video about programming the Sonoff Mini using this, and yes, these files will definitely be released, but the problem is the format for this header here. So the ESP programming header. And Aaron just said, could you do a multi-version Sonoff programming jig with your programmer and adapter built in? Yes, that's kind of where this is going. I don't want to try doing something that is like a universal programmer that will suit any type of Sonoff, but I've definitely thought about incorporating the USB directly onto the carrier PCB in here, so that this jig just has a USB socket on it, and then you just plug in USB, plug it into your computer, pop in your board, and then you can reprogram it. But I'm a little bit unsure about the economic viability of doing it that way, and the reason is that what it does is put a lot of complexity into a device that you'll probably only use half a dozen times. So something like this is really a convenience thing. If you want to reprogram a Sonoff, if you had just, say, one of these that you wanted to program, and you had a steady hand and a soldering iron, you could solder jumper wires onto the bottom of this and then plug those into a USB to serial converter and do the programming. If you want to go the next step for more convenience, say you were working in a house where you wanted to install a whole lot of these, maybe you wanted to reflash 10 or 20 of them, and then you didn't want to have to solder wires onto them, that's where this comes in. So Aaron said swappable pogo bed for versions. Yes, exactly. So that's where this is getting to. So what my intention is for this is that this is the pogo bed that is very specific to the Mini. It won't work with anything else, but it doesn't have any unnecessary electronics in it. It's just a passive PCB that takes the connections from those pogo pins and it brings them out to a standard header on the side. And then you could have a different pogo bed for a different model, which brings them out once again onto that standard header. What you plug into that is then the USB to serial converter that takes care of everything. So there are a couple of issues here. One is that to put an ESP8266 or ESP32 into programming mode, you need to be fairly specific for the pins. Sorry, I just saw. Yes, Scott said put a footprint in for a $2 Chinese CH340 board. Yeah, so that's an option. What you need though is also the control signals to be able to assert GPIO 0, pull it low, and hold it low while asserting reset and then releasing reset. And that's done typically by a couple of transistors using, I think it's the DTR signal coming off the USB to serial converter. So that part would need to be put onto the PCB, the little reset circuit. So, where is it? Over there. So now we get onto the subject of ESP programming adapters and header formats. Now this is a topic that I'm not really prepared for talking about today in great detail, but it's something that I do want to cover really soon because I personally have made a decision about what format I'm going to use for this. Now, I'm mentally trying to figure out here how much to backtrack and explain the background of this problem, because there are people on here who will know exactly what this problem is and others who won't have a clue what I'm talking about. Off DTR and RST. Yeah. So what this little adapter does is act as a programming adapter for ESP chips, and it's got this particular one has a CP2104 on it. I've also got a version with a 2102N, I think it is, and so it's got USB-C. There's a USB to serial adapter. It also has a little dual transistor, and it has headers for ground power, TX and RX, but it also has reset and IO0 coming off here. So if you have a matching header on your project, you can just plug this in, and then you have a programming interface with USB for your ESP project. What photo? Oh, wedding photo on the wall. Yes, it is. Which side? I'll get it backwards again. That one right there. Yes, that's a wedding photo, which is out of focus. Okay. David Grand said, pinout issue. Since you were using a passive connector to pogo pin board, you have 3 more edges. You could put some more pinouts for alternate compatibility. That's true. Is that, oh, Dodgy asked, is that new? No, that photo is 21? 20, it's certainly over 20 years old, just over 20 years old. It'll be coming up on 21 years old, I think. So we'll leave that squirrel alone for now. So this, I've really got to stop this. I keep going off on those squirrel quests and I can't remember what I was doing before. Yeah, so many squirrels. Alright, so what this board does is take care of that whole problem for you. All you have to do on your project is expose TXRX ground power, reset, and IO0. You don't have to have any of the other circuitry to control the reset process and those sorts of things. And Aaron said, how come you don't sell all these cool boards? This is the crux of the problem. It's the question of the order of those particular pins and whether the power that you supply to the target board should be passing through the 5 volts and then have it regulated on the target, or regulate it on this and pass through 3.3. And this is where I have a bit of a disagreement with with a few other people, and I've ended up finally deciding what I'm going to do. So I need to find the page, and then I will bring this up and switch my video view again. Alright, back to my desktop. So I have 2 different versions of this page. There is this one and this one. So I have, after a whole lot of looking around at different options for how to set these pins up, I distilled it down to 2 different options. And I could go into this in so much detail because I wasted so much time trying to figure this out. There are other people that have already approached this problem, and one very notable one is the board. There's a board called the WESP32, which is an ESP32 with onboard Ethernet and power over Ethernet support, which is a really cool little board, and I've got some of them here. And what that board does, let's see if I can find it. If I've got it easily handy, I may not. I'd probably have to go searching. I'm not sure where it is, but somewhere around I've got some WESP32 boards. No, I'm not going to go searching now while you're waiting. And yeah, WESP with a P, because it's ESP for ESP32. And there are so many different trade-offs to be made in terms of this design. And there is the order of the pins. So do we want the pins to be in an order that is elegant in terms of you look at the list of pins and it makes sense, or do we want it to be as compatible as possible with existing USB to serial converters so that the extra pins are not in strange places? Do you want it to be for easy routing on the target board? And all sorts of things. So these 2 pages are actually almost identical. One is at, in fact, I'm going to drop both of these URLs into the chat. There is this one, and the only difference between these URLs, I think, is a P and a hyphen. And what I did was come up with 2 candidates for how I wanted to do this. and the justification for why you would choose that particular thing. So the summary here is the pins that are required, which is pretty straightforward. We know what's going on there. And then header formats, whether it should be a 2x3 header or 1x6 header, or support both, whether it should be 0.1 inch or 0.05 inch pitch, or support both. And so what I've gone through here is listed all of the different possibilities, and then I've come down to these as the potential actual layouts. Now the one on the right, you can see the ESP prog 1x6. Oh, I need to change that label, that's wrong. The one on the right has ground GPIO 0, power, ESP, RxD, TXD, and enable. And this one is based on a board that was released on Tindy, I think it was, a little while ago, called the ESP prog. And it was a board that was designed to solve this problem, but there were some issues with it. I won't get into that right now. It's a very cool little board, it's quite nice, but it didn't quite do what I wanted. Now, one of the unfortunate considerations here is that all of this is being done in the context of what is IT going to do, and are they willing to make any changes to their programming headers? Because the ideal thing would be if IT modified the programming headers on their SONOFF so that they added the enable pin and the IO0 pin onto the header, and that would give us everything we need to be able to make a simple plug-in programming adapter. We could use something like this. And this partly comes down to, why haven't I released this yet? This has been around for ages. In fact, I wonder what the date is. Well, copyright 2019. I think it was early 2019 I designed this board, and I've been using them myself, and I haven't released them because of the whole question of which way is IT going to jump. Now, this pinout on the left that you can see here, with pin 1 being IO0, and then you've got reset. It's labeled as EN here because that's what it's called in ESP speak. Then ground, TX, RX, and power. This particular format I chose because it's based on the existing SONOFF header with the extra 2 pins added on the end. And I figured that this was the closest, this was the thing that was most likely to be adopted by IT and then added into their future SONOFF models. So I got in touch with IT and spoke to them about it. And they are very seriously considering adding this in future revisions of the SONOFF. And in fact, I got an update last week from a contact at IT, and this has, because I raised this with them, this went all the way through their engineering team and the owner, so the guy who owns IT, and they've been talking about how to implement this. And the most recent update that I had last week was that they want to do it, but they need to be careful in terms of their certification. Now, that might seem kind of crazy for us in Australia, considering that SONOFFs aren't even certified in Australia. But the reality is that SONOFFs are certified in many of their existing markets. So they're certified for sale within China, but they also have certification for sale in, I can't remember which countries, but they have proper certification in, I think it's in Europe and a couple of specific places. But they just don't have it in Australia because the Australian market is so small. But the upshot of all of this is that if they change their design, they need to get recertified, which costs money. And so I don't know whether this is just them fobbing me off or if this is actually a genuine thing, but what they are telling me now is that they want to do this. Dodgy said proper or Chinese proper. Well, they have proper certification for certain markets. They are fully legal to sell in some countries because they do have the proper certificates. And in fact, the certificates have been obtained for a couple of models in Australia by a third party. I've talked about that in the past, and I'm sort of drifting towards a squirrel now. So what this comes down to is, it is very likely that in the future we are going to see the programming header on Sonoffs extended to add the IO0 and reset pins, so that we can have an external programmer that just plugs in and works, and you don't have to worry about the rubbish of hold down GPIO 0 while you're powering it up and all of those sorts of things in order to be able to reflash it. And that would be fantastic. So but basically what it means is a design cycle at ITEED, or a certification cycle. So if they make changes to one of their designs, like the Sonoff Basic, and then they need to go through the whole recertification process, that's the point at which they might modify the programming header to add these extra things into it. And then we will be golden. But what I have not yet got is a 100% clarification from ITEED about whether they will use this specific pin order or if they will use something different. But my money is on this particular pin order because it's the minimum change that they would have to make to their system, and it also largely allows them to continue using their existing test jigs and everything else unchanged. Because you've got to think about this from the manufacturing point of view. They're making millions of these things every year. The numbers are truly staggering. Like the number of Sonoffs that they ship per month, it's in the six-figure region. It's amazing. And so all of their production line is set up for a very specific design, and if you change that, then you've got to change your test jigs, you've got to change your programming jigs, all sorts of things come into it. So part of my pitch to ITEED when I was talking to them about this was that this is adding 2 pins at the end of an existing header. The original pins can stay in the same place, they don't need to move anywhere. All you're doing is extending it by adding 2 more, and that means that your existing test jigs can continue to work, because you can just ignore those other 2 pins and test and use the 4 that are already in place. So where this has all come down is my personal decision, which I'm going to talk about in a video where I actually go through all of this in a more concise and planned way, is to use this format on the left, which is an extension of the format for the Sonoff, just with the extra 2 pins. And I'm going to use I'm going to use 3.3 volts, not 5 volts, being fed into the target device. Now, I'm just looking for a board. Oh, here's a bare PCB. Yeah, so I've already been using this on some things. So just as an example, this is a PCB, and I will switch back to, where's my control? Full screen mode. So this is a PCB for a prototype of the air quality sensor. This is going to be in part 5 of the air quality sensor series. And on the side, just there, is a 2x3 0.05 inch pitch IDC header, and that is the programming header, which is the 2x3 version of this. So if I grab this screen and scroll back down, back to the desktop, so scroll this one down. There is the 1x6 format, and a little bit further down there is an option for a 2x3 format, which can be either, is that any bigger? No, I must have a bigger version of that somewhere, which can be either 0.1 inch or 0.05 inch, and in this particular case what I've used is the 0.05 inch. Oh, and Scott said 0.05 inch pitch is the devil's work. Yes. It is kind of painfully small, but the thing is I started implementing this fairly soon after I started using USB-C connectors on my projects. In fact, this also has a USB-C connector on it, and once you have started doing footprints for USB-C connectors, everything else seems like a dream. USB-C is the devil's work. So what I've got on this is USB-C on the, come on, where is, there. So what I've got here is USB-C on this side, and I've recently changed over to a USB-C connector that just exposes the 16 pins that are required for USB 2 or 2.1. It doesn't do USB 3. And the result is that the footprint is dramatically simplified and it doesn't need through holes. With a normal USB-C connector, with the most common ones, what they do is they have a row of pins that are surface mount, and they have a row of pins that are through hole, and you have to account for both of them. And the pitch on those pins makes 0.05 inch look like you're using one of those jumbo crayons to draw with. They are so painful. In fact, the first time I sent a board off for fabrication with a USB-C connector on it, the factory contacted me and said, I think you've made a mistake in your design because there is not enough clearance between those pins. And I said, no, that's actually what it needs to be. And they said, okay, we'll make it. And I went ahead and fabricated it, and it worked, but it is so painful. Alright, so back on track. So this is where I've ended up. Either a 2x3 or a 1x6 programming header as an extension of the Sonoff header format with 3.3 volts supplied to the target. Now, there are many people who argue that what we should be doing is supplying 5 volts to the target and then letting the target do its own regulation, but I disagree with that for a few reasons. I went backwards and forwards on it originally, and I was kind of on the verge of being convinced to supply 5 volts to it. One thing is that it simplifies the programmer because you don't need the regulator on the programmer. You just pass the 3.3, the 5 volts through. But, well, you probably kind of do need it on the programmer because you still need 3.3 volts for the USB to serial converter. But coming at it from a purist point of view, oh, Johnny said 3:30 here, time for sleep, good night. Thanks for coming along, Johnny. Go to bed if it's 3:30. Oh, Christopher, you're here. 5 volt people are wrong. Yeah. So, and Dodgy said any way to supply both and switch between. That is what is done on some adapters, and I don't like it because it's potentially dangerous. So the arguments I have against supplying 5 volts on this is that 5 volts in this context is legacy. If you are dealing with an ESP32 device or an ESP8266 device, it's running at 3.3 volts. It's not running at 5 volts, and all its I/O is 3.3 volts. I don't want any way that I could potentially be shoving 5 volts into a 3.3 volt pin and damage the target. So if, and many boards, if you are designing a project for an ESP32, it may not be able to accept 5 volts coming in. it might only have, it might have like onboard battery management or something else, but there might not be a convenient way to actually take 5 volts in and regulate it down. So I really think if you're going to be going 3.3 volts, then you have to consider 3.3 volts as being native. That's what you run at. It's your VCC, it's your I/O voltage. So only expose 3.3 volts on the programming header. Don't make the header a mix of 3.3 volt and 5 volt voltages, because it's just asking for trouble and potentially being a pain for the design of the target board, which may or may not have a regulator where you can shove that in. So yeah, that's where I kind of ended up on that. I had a couple of people, like the designer of the WESP32 was having a bit of a discussion with me on this on Twitter, and I YTFP Chris said, make it 3.3 and 1.8 just to shut the 5 volt folks down. Oh, Vanquisher said, did I answer the question and I missed it, or did he miss my question? I don't know. Let me see. Hang on, Vanquisher. So have you looked at the Data Smart inline switches as a certified alternative to Sonos? Yes, I have some Data gear here, but I will. Scott says 12 volts definitely out, but I will not get into that right now because that's another squirrel. So Xeon said CP21OX doesn't need 3.3, it can just use 5 volt and regulate itself as it has an internal 3.3 volt regulator. Yeah, so that means you could avoid putting the 3.3 volt regulator on there. Anyway, it's one of those situations where the more I looked into this, the more trade-offs I discovered, and I ended up making a big spreadsheet that listed all the different possible programmer pinouts and potential problems. Like, you got to think about things like, what happens if someone plugs the programmer in the wrong way around? Is that then going to expose your target device to a nasty reverse voltage, or put VCC on a pin that can't handle it, or whatever? So there are so many considerations. And it got to the point, you know what it's like when you're trying to solve a problem and you can see all of these solutions. None of them is the actual golden solution that solves every problem, and you just think, that's like the least bad. That's what I'm going to use. And that's kind of how it came about with this. So I went to, so where I ended up with is this header, extension of the Sonoff programming header, the extra 2 pins on it, 3.3 volts. That's where I've ended up. In the process of doing that, I ended up doing a couple of different versions of this programming board. I've done versions of this with both of the different header layouts, like the 2 leading contenders of the header layouts. And because I changed my mind partway through the process, I ended up I did a first version of the board, then I did a second version of the board, and then I changed my mind and I thought, no, the first one was better all along. So this is actually the version 1 board, and it is where the pinout has ended up. So, getting way back to the start of this conversation with this little pogo bed for the Sonoff Mini. Got the 6-way header on the side, and that 6-way header happens to look a hell of a lot like this one on the left. And then little programming adapter, and plug them in, and wow, now we have a Sonoff Mini programming device with USB-C on it. You can plug it in and program your Sonoff, and then you can unplug this, grab a different little bed of nails, connect it in, program your Sonoff, and all of the logic is contained in this. The actual target adapter here is as dumb as it can be. It's just a breakout that links the 6-way programming header and it brings it up to the pogo pins in the most appropriate way for whatever you're trying to program. That's the end result. That's where I'm kind of going with this. So it's really only after last week, when I last had contact with IT, and they said to me the only reason that they're not doing this now is they need to get past the certification hurdle. That is the point at which I finally felt comfortable that I could share this with people and put the design out there. Because what I really don't want to do is go down the track of doing all of this and coming up with the interface on here and the programming header, and a week after I do that, IT'd release a new version of the Sonoff and it's got the programming header in a totally different format. And then we're all back to the drawing board. Well, not really, because what I would then do is just throw out every one of these that I have and do a new version that suits whatever header they come up with. But the problem is that I'm also designing the programming header into boards like this. So it's not just the adapter and the breakouts for the Sonoffs that matter. Once you start going down this track and you begin using this header in your projects, it ends up in everything. Like that big funky thing there, that controller that you can just see that's a little bit out of focus, that has one of those programming headers on it. So I'm using this header format for commercial projects for my clients as well. And I really don't want to mess it up. Doug said, sell a new version to everyone. That seems to be a common business model these days. Planned obsolescence. Yeah, okay, so Peter said, there's something here about the details. I've got to go back in the chat just a little bit. Vanquisher said, cheap, certified, flashable, want to pick up a couple. So that would be talking about the Dita brand devices, and very easy to program with the header they provide. Yeah, so there are a few other options. I mean, I keep talking about Sonoff, but they're really only one of many devices that are out there now. Since they kind of proved that the market exists, everyone else has jumped in and started using ESP8266s in their devices. And yeah, so Dodgy said, so IT isn't against the idea, it's more a case of being able to implement simply. Yes, that's exactly right. So I think IT actually quite like the idea. From the interactions that I've had with them, IT are quite open to people doing things and hacking their devices. They've done a couple of things over the years that have made people say, the sky is falling, IT is trying to lock us out. But I don't think they are. I think what's happened is that they've made a couple of engineering decisions along the way that people have interpreted as locking people out, and then when they realize what's going on, they back off from it. For example, when the Mini came out, it doesn't have the programming header on it. It's only got these tiny little test points. So initially what happened was this came out and people bought them to flash them with Tasmoda or Esperna or whatever they want to put on it. And I opened it and went, there's no programming header. We're being locked out by IT. They're finally coming down and stopping us from doing what we want. But IT specifically put a jumper on this to put it into programming mode so that you could load your own firmware on it. So they're not against the idea of people replacing the firmware on these things. They know that a large part of the reason for their success is that people have found ways to get their own firmware onto them and aren't locked into an ecosystem that could change or die at some point. Now, one of the things that I really like about these devices, and also others, there are one device that I don't mention enough, and I should, is the Shelly range of devices, and there are a couple of others as well. What I like about those is because it's possible to run our own firmware on these, it's impossible for these to be bricked by the manufacturer. Or if the manufacturer just goes out of business, then all of our devices are paperweights, because we can always run our own firmware on them. Yes, okay. Where were we? Yeah, so IT isn't against the idea. It's just a case of being able to implement. Yeah, they're very open to the idea. It just takes a while. There is inertia in scale manufacturing at scale, which they are doing. Okay. Peter Kirkos said, Dita's almost use the same circuit and components as IT when it comes to the switch mode supply. They're just made better in terms of isolation and Australian specs. I would be really interested to do a side-by-side comparison, because from what I've seen, the production quality of Sonoffs is very good, and they, in terms of how they work, they meet Australian specs. They just haven't gone through the certification process. But that's not because of any technical limitation. There's no reason that you couldn't take a Sonoff, get the lab tests done, get the certification done. It's purely economics. And there's nothing technically wrong with them that stops them from being certified. So it would be really cool actually to have something like a Dita device, and maybe some more of a big brand name type thing, like trying to think of what there would be now. But there are a number of larger manufacturers that have started using ESP8266s in the form of 2-year modules, and have them all open on the bench side by side and do a bit of a comparison, see how they handle things like isolating the 240 volts, which technically is called low voltage. So the low voltage 240 volt side from the logic level voltage side. And see if they are different. All right. Scott said, I'll give up on Sonoff when they start acting like yet another 2-year device maker. Yeah. I think what is good about them is that they are not just sticking a module on a board and then leaving people to their own devices. So they are quite helpful. All right. Peter said, Dita split the high voltage and low voltage onto 2 boards. Yeah, that's cool. IT do that on some of the Sonoff models as well. Like the touch switches, for example. The T4 EU1S touch switch that I did a teardown of ages ago now. Did a video showing how the no neutral touch switch works. They have 2 PCBs. So there is a PCB in the back of the enclosure which has all of the main stuff on it, and a power supply, so it provides 3.3 volts. And then there is another PCB which has got the ESP8285 on it and the touch circuitry and everything else, which plugs into the mains level PCB with a little header, and it just has logic level coming up to it. So that sort of thing is done in some Sonoff models as well. It just depends on the physical structure of how they have set it up. Alrighty, now, where am I at? Oops. I don't know. So many threads of videos that I could pursue. This is part of my problem, is that I've got, so I'm still deep in the air quality sensor project. I've got PCBs for part 5. In fact, these have got problems on it, so I need to do a revision of that PCB. And I've got the Sonoff programming adapter, and I've got these and all sorts of other things that I could be working on. And the problem is that I see something like, well, just recently it's been the light switches that have got my attention again, because people say, when are the light switches coming out? And I think, oh, I better work on that. And then, when is the Sonar programming adapter coming out? Oh, I better work on that. And the end result is that nothing gets done. So what I'm trying to do now is pick something, some path, and going down that down that route until it is a little bit closer to being done. Yeah, and the big question is which thing. I'm kind of spinning my wheels a little bit at the moment because I'm in that indecision state where I've got a number of things that are all extremely interesting, and I want to pursue them all, but I can't really put the time into them all. Like Aaron said, sorry, no pressure intended. Don't worry. Dodgy, I think you have a certain interest there. I can't really quite tell which thing you'd like me to work on. Maybe you better say it again. Yeah, James said, that sounds like all the projects at work. When will X project be done? Yes. The thing is that the Sonar programming adapter is kind of a foundational thing, and it's a building block for so much else, and it's going to come into things like the air quality sensor. So when the air quality sensor part 5 video comes out, it's going to be a little while yet, unfortunately. So part 4 will come out first about the software and using Grafana and all that sort of stuff, and then part 5 will be the pro version of the sensor. It will have a programming header on it that will need a programmer to talk to, although it can also be programmed directly because it's got its own onboard USB interface. So I'm kind of tempted to put some time into finishing off the ESP programming adapter and get that out, because once that's done, that can be used in whatever other projects I'm working on, and I then don't have to care about it anymore. It's just the decision is made, that's the header, I put it on the project, I've got a programming adapter for it, and it's out of the way. Stephen Harrison wants to know more about the squirrel. Well, it's got a big bushy tail and it's really fast, and I can never quite focus on it because it keeps zipping off in different directions. So that's my problem. John Raymond asked, what does the OLED screen between the feeders in your pick and place do or show? And that, I'll get back to Aaron's question. So at the moment, all it does is show the status of the feeders. The pick and place machine has currently, it has 3 controllers on it. There's the main motion controller. There is the controller for the head, which controls the servo and the vacuum solenoids and things. And there is the controller for the feeders. So the feeders, in fact, I've just been working on this over the last few days. Where is it? Feeders. I have a whole box full of feeder stuff here somewhere. There we go. This is the old feeder controller board, which has now been replaced. This is all replaced with IDC cables, and it's all much neater. So, and there's this one. So, inside the guts of the machine is an Ether Mega with a shield on it and a whole lot of connections. There's a little OLED on here, and these are the connections that go out to all the feeders. So each one of these is a 4-pin header, and the result is, well, so I've made a few of these shields and set them up in different ways. This particular one has a 128 by 32 pixel OLED directly on the shield, and the firmware that runs on this displays the feeder status on there. So when it starts up, the feeders are all disabled by default, and then OpenPNP sends a command to it and says advance feeder 3 by 4 millimeters, or something like that. But it won't move unless they've been explicitly enabled first. So on the OLED, I show whether the feeders are enabled or not. Right now, that's all it does. But my plan had been to keep a count of feeds on every feeder individually, so that what I could do is display on the screen feeder 3, 2,753 placements, and count it up, and have that number incremented and then stored in non-volatile memory, so that when it starts up, it knows the counts on all the feeders. I don't even know why I want to do that, other than the fact that it seems cool to keep a count of how many times each feeder has been activated. It might be a little bit useful in terms of predicting when a feeder is going to run out of parts, because I know how many parts are on a reel, depending on the type of part and the reel size and that sort of thing. There's typically 4,000 or 5,000 or 6,000 parts on a reel. So on the counter, I could keep track of how many I've dispensed from a reel. And this is I think it's the same. Yeah, this is the same revision of the board. It's just that this one doesn't have the OLED mounted on it. It's got headers instead. And what I did was use one of these 4-pin cables and take it from that header up to the display. So in the middle of the front rail of the pick and place machine, between the two banks of feeders, there is a 3D printed enclosure. Unfortunately, I have to do a whole lot of hand waving here. I can't grab the camera and just show you because I'm on a single fixed camera right now and I don't have many other options until I get more HDMI capture devices and I've got more flexibility. So there is the 3D printed enclosure in the middle with the display on it, and that display connects back via one of these cables to the controller board, which is sitting in the bottom. And at the moment, all it does is display a message that I think says something like feeders disabled when it starts up, and then when you enable the feeders, it says feeder set ready, something like that. Yeah. And the reason I've been screwing around with all these feeders is I'm just building more of them, because you can never ever have enough until you run out of space on the machine. I'm making another 3 feeders right now, which will take me up to 24, which is the most that I can physically fit on the front of the machine. If I wanted to go beyond 24, I would have to bring the machine out on a trolley or something, so that I could then put another set of feeders across the back. So I could put 24 across the front, 24 across the back. In fact, I could fit a few more on the back, because there's a little bit of space at the front taken up by the upward-looking camera. The 2 feeder banks have that space between them, and then there is the camera just near it. And yeah, then I could fit maybe 28 feeders across the back, but it also depends on the size. Most of the ones on the front are 8mm feeders. They're designed for tape that is 8mm wide, but the 4 that I'm adding to it now are for 12mm tape. I want to be able to put bigger things on there, so I'm feeding things like SMA diodes and the 500 milliamp polyfuses. They come in 12mm tape. So in fact, right now on my bench, just out of view, this is a 12mm feeder that I was building last night, and it's partially complete. You can see where is the focus on this camera? Okay, so you can see the insides of it. There's the little breakout PCB, which has got the flyback protection diode on it, and the connector for the bottom, and it connects to the servo here. There's a micro switch back here. And the micro switch is for detecting tape tension. The tape feeds up here, over here, and it pulls down and clicks the micro switch. And inside here, that's a this is like a bounce stopper. That's a spring-loaded thing, so the path of the tape comes up through here and is clamped down by this little spring-loaded mechanism, and then comes along here, and then it goes back down and is ejected down through the bottom of the machine, with the pickup point being right about here. So this is incomplete. There's still more mechanism that needs to be installed into this. This was as far as I got last night. There is another piece of the mechanism here. In fact, I could just drop it in place. This is what advances the tape. There's a little pointy bit there, and what this does is act like a ratchet. It slides back and hooks into the holes, the indexing holes on the side of the tape, and then it moves forward, and it just pushes the tape forward by pushing in these holes. And it's got a little swing arm on there and a guide pin. This connects to the top of the servo. So once this is all in place, it goes in here. You can see it moving backwards and forwards. So it normally sits there and it slides backwards, hooks into the next hole, and then slides forward and pushes the tape forward. And normally just in here is where there would be a little horn on the servo. So this lever is attached to the top of the servo as the servo pulls it back and then pushes it forwards. And there are a couple of other bits that need to go in there as well. And then there is the tape peeler mechanism that goes on the back. So Aaron said, whose design is that? That was done by a German guy named Michael. All I know about him is his first name is Michael, and it took a long time to find that out, and his initials are MGRL, so he's known online as MGRL. That's pretty much all he's known as. He seems to be a bit of a private person. As far as I know, he doesn't have Twitter, Facebook, or any of the normal sort of social media stuff. James asked, how many boards do you build at your house? Not very many, really. How many? I'm probably going to be doing more, because of these current circumstances. I'm doing more now than I have in the past, is the summary. In the past, if I've had to do any more than maybe 20 to 50 boards myself, I've just farmed it out to a Chinese assembler, and that is becoming more difficult these days. So hi, thanks Aaron. Yes, I'll get back to that. I'm probably going to be doing more batches of boards locally, probably in the orders of hundreds of boards at a time instead of 10 or 20 boards at a time. I'm not quite as crazy as Sion, who does large numbers of boards himself, but well, I've got to do what I can sometimes. Just looking for an example. Oh yeah, like this one. This is a just recently I ran a batch of these 8-channel relay driver boards on the pick and place, and they are currently not in stock. In fact, let me see the stock level. Yeah, stock level is 0 on the SuperHouse site. So these 8-channel relay drivers, this is one that came off the batch, just completed. There will be a big pile of those going back in stock soon. And they were all assembled right here, parts put on with this pick and place machine. In fact, that video that I posted a few days ago, I put up a video which was a complete run of the pick and place machine from homing through to the completed board. That was actually making these boards. And okay, so sorry, Aaron. I had forgotten about your question. Aaron said USB-C on programmer. Yes, this is a USB-C connector, and what it's doing is It's running in USB 2.1, I think it is. I can never remember the specific spec numbers and what they relate to. So it's backward compatibility mode. The USB-C connector can support a whole lot of different protocols on it. It can support USB 3 and faster, and it also can do things like Thunderbolt, and so you can run video over it and all sorts of things. It's basically a hodgepodge connector that allows you to shove a crazy number of different signals through it. But what I really like it for is the mechanical reliability. Just in the little amount that I've used them, USB-C connectors seem to be far better than micro USB in terms of, well, firstly, they're reversible, which is awesome. It's the way it should be. And but they're mechanically a lot stronger. It's going to be really hard to rip a USB-C connector off a board, but micro USB connectors, they just come off all the time. It doesn't take a whole lot of force. In fact, when I'm trying to find an... Okay, here's an example. Not that you'll be able to see it. This board under here, which is a Freetronics 11, it's got a micro USB connector on it. What we had to do in setting up the manufacturing for these particular connectors was a couple of things. We needed to, at the factory, well, the first step was there is wire stitching directly under the connector that bonds the top layer copper onto the bottom layer of the PCB. So this PCB is 2-layer. There is a ground plane on both the top and the bottom, and there are vias, or if you insist, vias, that go through the PCB and that join the two ground planes together. Now, vias are normally used for electrical connection to take a signal from one side of the board to the other. They can also be used for thermal stitching and mechanical stitching. And what it does effectively is, if you have a PCB which is a sandwich, so it's got a top layer of copper, then it's got fiberglass, then it's got copper under it, the top layer, the fiberglass is only glued, the copper is only glued to the fiberglass. If you apply force to that layer, like through a solder joint, you can peel the copper off the fiberglass, and you can do things like rip connectors off. So what I did in this particular case was put vias that go directly through between the two layers, and they act as a mechanical anchor. It's like putting dynabolts into concrete to attach a metal plate to it. So what it's doing is going through and attaching to the bottom part of the board, and then if there is mechanical force that tries to peel the copper off the top of the board, it is also applying that force down through the vias and to the bottom layer copper, and the whole lot is bonded together. So it dramatically increases the strength of the pads on the top of the board. So that was one thing that was done in the design. The second thing is that in the factory, we specifically got them to apply extra solder to the pads. There are in this one there are 4 mechanical stakes. So there are pins that go through holes in the board, and that provide some mechanical support for it. So it's not relying just on the electrical pins on the back. And in fact, the idea is that you should take all strain away from the electrical connections and just have mechanical strain going through the physical connections. So in the specifications to the factory, so the Chinese assembler, what we did was get them to increase the amount of solder paste that is applied. There is a technique you can do which is applying solder paste to through holes, and the mechanical stakes that go down through and mount this connector go into little through hole slots. So we got them to apply extra solder paste going into those holes so that when the socket goes on, it has a better solder joint. So the good thing is that with all of the many tens of thousands of boards that we've produced with micro USB on them, the number that have had their sockets ripped off is remarkably small. but that's only because we had to go to a whole lot of trouble to make those sockets strong. So to rip these off, you've actually got to be trying. But the nice thing, wherever it is here, about USB-C is that in the design process they recognize that as a design flaw of typical micro USB sockets, and they made provision for it in the way the connector is designed. And mechanically it bonds to the board a whole lot better than a USB-C connector. So these connectors are incredibly strong. I haven't actually tried to rip one off, but yeah, you'd have to be working hard to do it. So upshot of all of that is in the last 12 months I've switched to using USB-C on pretty much all of my projects. I haven't put a micro USB connector on anything for ages now, and there are some specific projects where I've used USB-A, I think it is. It's the big square one, but that is for a very specific reason. Turn on super chats, please. I did not even know about that, or what the deal is with that. I'm going to have to look into that. I don't know what it takes to turn on super chats. I'll see. So I've gone past my self-imposed 2-hour limit, but before I go, since we're talking about USB-C, I'm going to show you something that I have just been working on, which is a major update to the Ether 10 board. And let's see, where is it? Should be here somewhere. I can't even remember what the project is called because I just changed it. Come on, oh, that's right. No, I renamed it to Ether Uno. Ether. There. Okay. I will switch to desktop mode in just a moment once I get this open. Alright. Back to... Oh, it's complaining about managed libraries because I was working on a different machine. Desktop. Okay. So, this is an updated version of the Ether 10, which has been around since, I think it was 2010. And so that's an awful long time for one design to be in production. It's time for a major update. Ether fiber! Yes. Could put a little a module socket on this to put one of those SFTP or whatever it is modules on it. Yeah, so this is I assume that most people here have some clue what this is. The Ether 10 is basically an Arduino Uno with onboard Ethernet and power over Ethernet support, and SFP Plus. Yes, that's right. That's the acronym I was failing to remember. And the current version of the Ether 10 has a WIZnet W5100 chip on it, which is now becoming... It's at the point where it's so old that you have to pay extra to get it because it's no longer a standard stock item. So it's becoming a manufacturing problem. But I want to stick to the... Aaron, I'll get back to that about PoE. But I want to stick to the WIZnet architecture because what I really want, one of the major design objectives for this is to make it a drop-in replacement for a combination of an Arduino Uno and an Ethernet shield plugged on top. And the official Arduino Ethernet shield started off with the WIZnet W5100, which is why we ended up putting it on this board. So all the examples would work. You could install the Arduino IDE, you load the standard library, the Ethernet library, and everything just works. So, and that's, I think, been a really good design decision. I didn't want people to have to download a different driver library just so that they could use this board and have different examples and all of that sort of thing. So what I've done with this is ripped out the spot where the W5100 would go, and I'm going to replace it. I actually started doing a version of this with the W5500, which is a newer version of a chip done by WizNet, but that has some different register setups, and it's not a direct drop-in software replacement for the 5100. And so instead, what I'm doing with this is going for the W5100S. Now, one of the problems with the 5100 as well is that it ran notoriously hot, and I would often get people contacting me and say, I've plugged in an Ether 10 and it's running really hot, there's something wrong with it. And I'd say, no, it's okay. The chip could hit 70 degrees and that's totally normal. You just got to live with it. And because of the popularity of the W5100, what WizNet ended up doing was bringing out the 5100S a couple of years ago, which is specifically designed to be a direct drop-in replacement. It's mechanically quite different. It's in a smaller package. The thermals are much better, so it runs cooler. It's actually cheaper, but from a software point of view, it works exactly the same as the 5100. So your software can't tell the difference. And so what I'm doing, this big hole you see in the middle of the board here, that's where the 5100S is going to go. And that will then, and the reason I brought this up is the whole USB-C thing. And you can see up in the top left corner of the design here, I've started doing a conversion to USB-C. I don't have the routing done here yet, and you can see that there are some overlaps because I just ripped off the micro USB connector and plonked this one over the top. But there will be USB-C on this. Now, getting back to that PoE question, there was a question earlier about what type of PoE. This supports either cheap DIY PoE, like shove 12 volts down the unused pairs, or 802.3 AF PoE, so 48 volts. And the way it does that is by externalizing the PoE regulation into a module. And I'm not sure if it's all that apparent on this particular view here. Let me switch to, not dimension, let's see, T-place. Okay, I'll go to the T-place layer in single layer mode. It might be easier to see here. So what you can see down here is a 4-pin header, and what this does is exposes the connections that come in from the RJ45 socket. So the RJ45 socket internally has transformers. Reconnection successful. That was strange. OBS just said that it disconnected and reconnected. Can someone confirm that you can still see what I'm doing? I'm not even 100% sure that I'm online right now. Okay. Oh, great. It's back. All right. I'm just going to do this last little thing and then I'm going to wind it up anyway. Thank you. All right. So inside this RJ45 socket, there is a little transformer, or a couple of little transformers that bring out the power connections. Those power connections then come to this header, and they are here in plus and minus because it's actually got its own little internal bridge rectifiers as well, and so this will expose either the whatever power you directly push down it, or the 48 volt PoE on the plus and minus connections. And this connection up here is V in, so this is power going into the board, and there is a ground connection. So what happens is that there is a module that sits on the top here, there is a mounting pin up near the top, another one down the bottom, and you can see the outline here. It's a little strange L-shaped board. It sits on top of this header, and you can either put in a module that has a switch mode voltage regulator, if you want to send like 24 volts down the wire, or you can just put jumpers across here. So if you send like 7 volts or 10 volts down the wire, what you could do is put one jumper between plus and V in, and another jumper between minus and ground, and then whatever voltage that you send down the Ethernet just goes straight onto the input of the voltage regulator on the Ether 10. And that means there's no extra cost. It's just 2 jumpers, which we even supply in the box. And you can run this over power over Ethernet. But if you want to run it on a commercial PoE switch at 48 volts, there is a different module that you put in here, and it implements the signaling on the power line and negotiates the power level with the injector, and then regulates it down and sends it down. I think from memory it's at 10 volts. It feeds 10 volts down into V in for regulation on the board. So what I'm in the process of doing right now is a major revision of the Ether 10, and it's being reborn, or it will be reborn before too long, as the Ether Uno, and it will functionally be an Arduino Uno with onboard Ethernet and PoE and USB-C. And I think I'm going to do this under the SuperHouse brand instead of under the Freetronics brand. But that's what I've been doing on my laptop while I've been sitting in front of the TV in the evenings, because that's what I like to do. Even like right up until the time I go to bed, I'm normally sitting there routing something in Eagle or writing some code, even when I'm in front of the TV. Anyway, I am now way over time. It is time for lunch for me and for many of you, and time to go to bed for many of you as well. David asked, did you figure out the PMS 5003 air sensor ESP easy has fixed? And I saw some Arduino code to address it. No, I haven't seen that, but thank you very much for pointing that to me. So I'll go and have a look at ESP Easy and what they've done in relation to the PMS 5003. If there is a fix that they have implemented that I need to do. So that could be useful. There are some strange things happening in the code that I've been running on the 5003, where I don't always get back values. So perhaps there is something that they fixed that I can learn from. That would be awesome. Okay, I'm going to stop talking now. Thank you very much, and a huge thank you to Sion, I'm not sure if he's still here, for giving it a go with that Skype call. I'm going to try to figure out a better way to do that. Skype is possibly not the way to do it, and also a big thank you to Guru of Nothing. I've got a whole list of things I need to remember. Aaron said don't forget the super chats. I will try to remember these things. So thank you for hanging in there through the strange technical difficulties. And now it is time to call this to an end. Thanks. Bye.